Good morning, class. This is Physics with Shemahai, and we are taking scalar and vector quantities, and it's week 1. Although these scalar and vector quantities will also go to week 2. So we'll be in today's class we'll be taking the definition, examples, differences, then we'll take similarities. Are you getting me here now? So let's start with the definition of scalar quantities and vector quantities. Are you getting me here now? Alright, now definition of scalar quantities. Now, scalar quantities, they are quantities that has what? Magnitude and do not have direction. So any quantity that have magnitude but don't have direction are scalar quantities. So let's write scalar here. Scalar quantity. Only what? Magnitude. Now, vector quantities. Now, vector quantities. These are quantities that have both magnitude and direction. I repeat, vector quantities are quantities that have what? Both magnitude and direction. Alright, so we have what? Magnitude and what? Direction. They have both what? Magnitude and direction. Now let's go to some examples of scalar quantities. Then we have some examples of vector quantities. Now for scalar quantity we have time. We have time, we have area, we have temperature, we have what? Volume, we have distance, we have electric current, we have electric resistance, and we have electric charge. Electric what? Charge. Now, these are some of the examples of scalar quantities, etc. Now, we have examples of scalar quantities. We have time, we have area, we have temperature, we have volume, we have distance, we have electric current, we have electric resistance, electric charge, etc. So let's go to examples of what? Vector quantities. Now, examples of vector quantities. We have velocity. We have displacement. We have force. We have acceleration. We have electric field. We have magnetic field. Alright. Because since I wrote it under the differences, I have to change that stuff to examples. So these are the definitions and examples of what? Scalar and vector quantities. Now let's go to differences of difference between scalar and vector quantities. Alright. Let's add scalar here. vector. Alright, so let's wrap here off. Alright, now let's go to the differences between scalar and vector quantities. Yeah, this one only have what? Magnitude. This one has what? Both magnitude and what? Sorry? Both magnitude, nitude, and what? Direction. Are you getting me now? There are differences. One has only magnitude, one has both magnitude and direction. So another one is its direction cannot be determined. Here one is its direction can be determined. So one direction cannot be determined, the other direction can be what? Determined. Alright. It is measured, take note, measured in arrows and lines. Sorry, it is not. It is not. It is not. It is measured in arrows and lines. Take note. Scalar cannot be measured in arrows and lines. Vector can be measured in arrows and lines. One more. Now, in this one, it is one-dimensional. Here, it can be one, two, or three what? Dimensional. Can be 1, 2, or 3 dimensional. So let me quickly go over it again in the differences. Now, scalar quantities, they only have what? Magnitude. They only have magnitude. Vector, they have both magnitude and direction. Scalar, its direction cannot be determined. Vector, its direction can be determined. Scalar, it is not measured in arrows and lines. It is measured in arrows and what? Lines. Then it is one-dimensional. Vector, it can be 1, 2, or 3 dimensional. So let's go to the similarities between scalar and vector quantities. Alright. Similarities between scalar and vector quantities. That should be our last one for today. Similarities between scalar and what? Vector quantities. Their similarities. Alright. We are taking 3. 1, 2, and 3. Number 1. They are what? Both physical quantities. They are both what? Physical quantities. So number one, scalar and vector are both what? Physical quantities. Number two, they both have magnitude. They both have magnitude. Then number three, their magnitude can be gotten through what? Through calculation. Alright? Alright. Now, I will go over the similarities between them again. Similarities between scalar and vector quantities. They are both physical quantities, number one. They are both physical quantities. They both have magnitude and direction. Their magnitude can be gotten through calculation. This is where we will call it a day for physics week 1. Remember that scalar and vector quantities will go over to week 2 also. We'll continue it in week 2. So continue with your scalar and vector quantities. I will give you the topic for chemistry week 2. Alright. See you guys in our next class. Have a nice day.
Finding it hard to understand your science courses? I got you covered. Subscribe now to Understanding Science on YouTube. At Understanding Science, we offer you the best of your physics. Projectile motion is the motion of an object projected upward at an angle into the air under the influence of gravity. Your chemistry is a combination of both Boyle's law and Charles' law. You get it? So in general gas law is a combination of Boyle's law and Charles' law. So and your mathematics. For special WhatsApp classes and inquiries, call 080-240-72621. Science made easy with Understanding Science.